Hey, welcome. Today, we're going to dig into a mystery that's literally right under our feet. We're talking about soil, and you'd be amazed at how it secretly shapes our entire world. So, let's get our hands dirty, shall we?
You've been there, right? You try to grow something, maybe in your garden or in a pot. You give two plants the same sun, the same water, and yet one of them thrives and the other just gives up. What is going on? Well, the secret isn't in the leaves. It's way deeper than that. It all comes down to these three main characters in our story, and just looking at them, you can see they're completely different. Let's meet the big three: sand, silt, and clay. These are the fundamental building blocks of pretty much all soil. So what makes them so different? You might think it's some complex chemical thing, but the answer is surprisingly simple. It all comes down to size. Just one tiny detail that, as you'll see, changes absolutely everything. That's it. Seriously, that's the big secret. The size of the tiny mineral particles that make up the soil dictates its whole personality: how it feels, how it holds water, what nutrients it has, and, most importantly, what can actually grow in it. Okay, check this out. It all starts with the particle size. Over on one end, you've got sand, with its large, coarse particles. All that space between them means water just rushes right through. Super fast flow, but it doesn't stick around. Then, on the complete opposite end, you have clay. Its particles are tiny, so they pack together really tightly. Water has a tough time getting through, so it moves slowly, and the soil holds onto it for a long, long time. Which, of course, brings us to the idea of a Goldilocks soil. One that isn't too fast or too slow with its water. One that holds on to just the right amount. It's all about finding that perfect balance that's just right for life to really take hold. So let's connect those dots. We know particle size affects water flow, but why does a plant care so much? Why is that detail, how fast water moves or how long it stays, so incredibly important for a plant that's just trying to grow? Well, this experiment just lays it all out perfectly. Look at that. On the left, with the sandy soil, the water is just flying through. Any good stuff, any nutrients in there, whoosh, they're gone, washed away. On the right, that clay soil is holding that water so tight a plant's roots might actually drown. But that middle one, that's our sweet spot. And that's really the key. Fertile soil, the stuff that plants absolutely love, is a soil that can hold on to some water, but not too much. That perfect medium allows it to also hold on to all the good stuff, the organic materials and nutrients that plants need to eat without choking the roots. Okay, so now let's zoom out a bit, because soil doesn't exist in a bubble. There's a much, much bigger force at play here, one that acts like a master architect for the entire landscape. And that force is climate. And you can really see the two extremes right here. On one side, you've got a world that's defined by water, by humidity. On the other, you have a landscape that is just baked by heat and dryness. Climate takes the natural tendencies of soil and just cranks them up to 11. So in those really humid, rainy places, the constant downpour can actually become a huge problem. The soil gets totally saturated, and all the essential nutrients for plants get washed deep down into the ground out of reach. Sometimes that can form a hard layer that roots can't even break through. Worst case, you get waterlogged soil, so full of water there's literally no air left for the roots. Now let's flip that coin. In hot and dry climates, you've got the complete opposite set of problems. If your soil has a lot of clay, the sun can bake it into a crust that's as hard as concrete, and water can't even get in. If it's sandy soil, any precious rain that falls just vanishes in an instant. This is a big reason why you don't see massive forest in many deserts. The soil just can't hang on to the water long enough. And this is where it all comes together. The type of soil, supercharged by the climate, doesn't just decide which flowers can grow in your garden. It dictates the entire ecosystem. It literally builds two completely different worlds, right from the ground up. Let's start with case study number 1, the savanna. Picture Central Africa. The very foundation of this incredible environment is its dry, sandy soil. It's like a chain reaction. Because the sandy soil drains water so fast, it can't support big, thirsty trees. But it's absolutely perfect for tough grasses. And an endless sea of grass supports massive herds of animals that eat it, like gazelles. And of course, where you find gazelles, you'll find predators, like lions and cheetahs. It all starts with the soil. It's the first domino to fall. Now, for something completely different, let's look at our second case study, the bog. This is a world built on the total opposite foundation. wet, dense, clay-rich soil.
Here, the clay acts like a giant sponge, holding water so well the ground is pretty much always soggy. That creates this unique, cool, moist environment that's perfect for very specific kinds of plants. And that wet, plant-filled world becomes the ideal home for animals like frogs and mosquitoes. A totally different ecosystem, all because the soil holds onto water instead of letting it go.
So after seeing all this, it becomes so obvious, right? Soil isn't just mud or dirt you wipe off your shoes. It's the foundation. It's a literal blueprint for what kind of life can be built on top of it. Which leaves us with just one final thought. The next time you step outside, wherever you are, just take a second. Look at the ground, look at the plants and animals around you, and ask yourself, what blueprint are you standing on?